Before we get started in this video, I need to make something very clear. These are numbers that I came up with in my head. You are going to be using the values that you got from your lab after finding the averages of the hydrates and the anhydrides. For this example, I'm going to use the magnesium sulfate heptahydrate. That's going to be salt 2. And what we are going to find out is, were we accurate? And if so, how accurate were we? Will we end up with this 7? We don't know. So that's essentially what we're going to be calculating. MgSO4 blank hydrate. So we need to figure out, were we precise enough in the lab to get 7 as our value? So as I'm going through this, please keep in mind, these are not the actual numbers you should get. Every person and every lab should get different numbers depending on how many grams you started with. I didn't tell you exactly how many grams to start with for that reason. It's supposed to be an approximation. So essentially what we need to compare our anhydride, that's our magnesium sulfate, to our water, grams of water. But remember what this means now. Hydrate means it is hydrated. That's what we started with. Anhydride means it is dehydrated. The water evaporated out of that salt solution. So in order to find out how much water evaporated, we need to subtract the total from the part. So the anhydride was just the part of it. So we should get 0.03 grams of water in this situation that evaporated out of it. So what we need to do with this information is we need to convert it to moles. So we could set up a mole to mole ratio, because this value right here represents moles or molecules. So grams isn't really going to do us any good. So I'll go ahead, I'm going to start off with the water. I have 0.03 grams of H2O. I'm going to use dimensional analysis, that's just a fancy way of converting numbers, to convert this value to moles. If my grams of H2O was on top, then grams of H2O should be on the bottom. We're going to get that value from the periodic table. So I'm going to put PT here for periodic table in case you need to pause and kind of look at it and get your bearings again. We're getting these values from the periodic table. So I just have this one memorized. 2 hydrogens plus 1 oxygen is 18.01. And that's going to give us how many moles of H2O we have. Please notice how labeled everything is. I have a label on everything. That way I don't lose my work and I know where everything is. I just type the value into my calculator and I get 0.00167 moles of H2O. And I just rounded it. It doesn't really matter where you round it to, because we're eventually going to have to put it in a ratio of this to that to make it work out. So next part, we're going to find the moles of anhydride, that value we get from here. We keep that separate because the whole thing together is the hydrate. But I just want this part and this part. So this is the water, this is the anhydride. So I'm going to do 0.5 grams of magnesium sulfate. And I don't have that value memorized, so I'm going to pause myself for a moment and ask Siri what the molar mass of magnesium sulfate is. All right, he told me the answer is about 120 grams per mole. And I do know that this is a rounded value. I am well aware that there are some decimal places after that, but it disappeared too quickly for me to see anything, so I'm just going to do the very best with what I have. Remember, this video is about figuring out how to do these calculations. So as long as you understand that this value of 120 is rounded, then you're in good shape. So we're going to use this to find the value of the moles of magnesium sulfate. I need to divide. and that gives me approximately 0.00417 moles of MgSO4. Now what I have to do is create a ratio, magnesium sulfate to water. I'm going to put the water on top all the time because I want this value to give me a number, a whole number preferably. So let's see how close my guesstimated values were. So I'm going to take my moles of H2O, 0.00167 moles of H2O over 0.00417 moles of magnesium sulfate. Those are some really strange and weird numbers, but once we divide them, they should end up getting us something that makes a little more sense. Now, in this circumstance, quite frankly, it does not. I did not get very good values. I got 0.4 as my number. So the only thing I can really do is I can round that to the nearest whole number, which would get me 1. Totally wrong. Okay, but remember, it's about the process. So this means I made some sort of terrible error in the lab. So I would consider this one kind of a bust. Now, what I would do then, in purple, I'm going to put this in, is you would make this your obtained value, O, whatever value you end up getting here. This value that was given to you in class, so for magnesium sulfate, the hydrate level is 7, and for the sodium chloride, the hydrate level is 1. That is your actual amount. And you're going to plug it into the formula. You take the absolute value, which just means make it a positive number. Your absolute minus your obtained, your actual minus your obtained, divided by your actual number times 100. That gives you percent error. That goes back to the very first quarter when we started calculating our percent errors in there. In this circumstance, my percent error would be through the roof because simply I didn't come up with a good good numbers to start with. But that would have been a very extreme case, which is rare. But as you know, things happen in the lab. So what's really important is the process, knowing that you're only working with your anhydride and your water. Once you obtain those values, and remember these are coming from the averages of your 3 trials, you convert them to moles using your periodic table, and you set up a mole ratio. That's the key. If you have any specific questions on this video, please reply to the post, and good luck.